question 9, and I think we've got a really nice set of questions here, considering we're late on in the paper. We've got someone kicking a football against a wall. It tells us that the mass of the football is 0.42 kilograms. Beautiful, don't need to change it. Then it tells us how much GPE it gains as it rises up above the floor. 11, beautiful, don't need to change that. Calculate the height. So GPE equals, and we've got MGH on the bottom, or we can see we want to rearrange for the change in height, and it's currently multiplied by mg, so we're now left with h equals GPE. We've got to divide both sides by m, divide both sides by g, and there we go. So as long as you know how to arrange, or you can remember your formulas, that's great. And then we're ready, we can just plug the numbers in. So h equals GP over m times g. The GP is 11, the mass is 0.42, gravity is 10, and we get 2.6 meters. Calculate the kinetic energy, and it tells us k equals half mv squared. That's the mistake that people make, they forget to square when it's moving at a velocity of 12 meters per second. So if I just go and rub all of this stuff out, I'm going to need to know the velocity is 12, and I'm going to need to know that mass. And in my calculator, I'll use 0.5 times the mass times the velocity squared. So pull it up. So k equals 0.5 times the mass of the football, 0.42 times 12 squared, 144, equals 30.24 joules. It says, describe the energy transfers that happen when the ball hits the wall. Well, we can see the ball's got kinetic energy. That's going to go into elastic potential energy when the ball squashes. Then as it falls, we're also going to, get some heat energy. Let me just get rid of that GPE. So we've got kinetic energy, it's going to go to elastic potential energy as the ball squashes. That's going to make heat energy that will dissipate into the air. And if I wanted to, we've got some KE going back, and again, we've got EPE and thermal energy there. Okay, so KE transfers to EPE, elastic potential energy, as the ball squashes against the wall. Also, some thermal energies transferred into the wall and into the air. Right, this next one looks really tricky for a 6 marker, and it isn't. It's look at the graph, explain these patterns. But the crucial part is you've got your answer. So explain how these values change. You've got to talk about the trends. Well, we can see the trend is, if I was to draw a line, this one goes down. So non-renewable decreases over time. That's 1 mark out of 6. If we look at renewable, these increase over time. There's a 2nd mark and a 3rd mark, and then in this period here, they're roughly the same. There's 3 marks. Now the next part is we can see the trends up, then we've got to explain why. So non-renewable, they're decreasing over time because we're running out of them. There's only a finite amount of it. And then renewable energy, they're increasing over time because they don't produce carbon dioxide, which helps with global warming. And we've got this energy mix over time. Done. The only other thing I've then got to do is use the numbers. So you can see here, and they're roughly the same from about 2019 onwards. And then I can say it's going to decrease from around 24 terawatts to 12-ish. This one's going to move from 4 to 10, and then I can just talk about that change. So it looks horrible. Loads of people left it blank. It's actually quite a nice question. So as time increases, non-renewable energy resources decreases. Done. By, and then tell the examiner the amount. So by 12 terawatt hours over, is that 8 years? This is because they are finite resources and they produce carbon dioxide, which leads to global warming. Okay, going on to the next part. I've put in there brackets, taking nuclear energy out of it, which you know my feelings. I think we should use more of that. So the next part, as time increases, renewable energy resources increases. That's the trend. By 4 terawatt hours. And this is because they are sustainable and do not produce carbon dioxide. And then I'll just put some in there, for example, solar and tidal. And there you go. So it looks like a horrible question. It's actually quite pleasant.